In this video, I will analyze the sign of heat, work, the change of internal energy, the change of enthalpy, the change of pressure, the change of volume, the change of temperature, and the change of the product of PV of an ideal gas in an adiabatic, isothermal, isobaric, or isochoric process. Let's look at the adiabatic expansion first. Adiabatic means Q is 0. No heat exchange. Expansion means delta V is greater than 0. Volume increases. And when volume increases, the system does work to its surroundings. Therefore, work is negative. Delta U equals Q plus W. Therefore, delta U is negative. And U is internal energy. Because it's an ideal gas, the potential energy of an ideal gas is always 0. When delta U decreases, it means the kinetic energy of the ideal gas decreases. And temperature is a measure of the average kinetic energy. Therefore, when kinetic energy decreases, temperature decreases. And when temperature decreases, of course, this delta PV decreases. This is because when temperature decreases, nRT decreases, and therefore PV decreases. If delta PV is negative, delta V is greater than 0, delta PV is less than 0, what does that mean? Volume increases while PV decreases. The only explanation is delta P is negative, pressure decreases. And finally, enthalpy also depends on temperature only. For an ideal gas, delta H is the integral of Cp dt. So when temperature decreases, enthalpy decreases. There's another way to analyze delta H. H equals U plus PV. And you can see delta U is negative, delta PV is negative, therefore delta H is also negative. All right, how about this column? This column is adiabatic compression. So really, if you see a less than, just change it to greater than. If you see a greater than, change it to less than. And if you see an equal sign, just keep the equal sign here. That will solve this column. And then isothermal expansion. Isothermal means the temperature is constant. Expansion means volume increases. So first, isothermal, the temperature change is 0. Expansion, the volume change is positive. And then if temperature change is 0, that means the nRT remains constant. Therefore, PV remains constant. If PV remains constant and volume increases, pressure must decrease. All right, and again, we mentioned that U and H of an ideal gas only depend on temperature. The higher the temperature, the higher the U and H. Therefore, we have delta U equals 0, delta H equals 0. Another way to analyze this is, again, temperature is the measure of the average kinetic energy, which remains constant. And also for an ideal gas, anyway, the potential energy is always 0. Therefore, delta U is 0. Delta H is equal to delta U plus delta PV, and both delta U and delta PV are 0. Therefore, delta H is 0. Now, since volume increases, the system expands and does work to the surroundings. Therefore, work is negative. How about heat? Heat must be positive. That means the system absorbs heat from the surroundings and then does work to the surroundings. Overall, the internal energy of the system remains constant. So how about this column? Again, you just look at this signs. When you see a greater than sign, you put a less than sign here. If you see a less than sign here, put a greater than sign here. And if you see equal signs, just keep those equal signs. How about isobaric isobaric process in which temperature increases? Well, in an isobaric process, delta P is 0. No pressure change. And if temperature goes up, delta T is greater than 0. And when delta T is greater than 0, delta PV must be greater than 0. And delta U must be greater than 0, and delta H must be greater than 0. So you probably have seen the trend. Delta U, delta H, delta T, and delta PV, these 4 items must have the same sign, delta U, delta H, delta T, and delta PV. They are all proportional to each other, so if delta T is greater than 0, and then delta U, delta H, and delta PV are all greater than 0. All right, since we're looking at this, PV increases while this pressure remains unchanged, therefore volume must be increasing. And if the volume increases, work must be negative because the system does work to its surroundings. And since delta U is greater than 0, that means the energy, the internal energy of the system increases, while the system loses energy to its surroundings by doing work. Therefore, Q must be greater than 0. And the magnitude of Q should be greater than the magnitude of W here. All right, how about this column? Again, this column is simply the opposite of this first column. How about the third column? Isothermal expansion. Isothermal means delta P equals 0. All right, and then expansion means delta V is greater than 0. And actually, when you have these two conditions, and if it's an isobaric process, delta T is proportional to delta V, so delta T is greater than 0. So honestly, this column should be exactly the same as the first column, but still we can just analyze every single item. Delta T is greater than 0, and as we mentioned, delta U is proportional to delta T, delta H is proportional to delta T, delta PV is delta nRT, and also when volume increases, the system does work to its surroundings, and then Q must be greater than 0. How about this column? This column is exactly the same as this column. Now finally, isochoric processes. So let's look at this isochoric process in which pressure increases. So isochoric means delta V is 0. And then pressure increases, delta P is greater than 0. Therefore, the product of PV must increase because, again, volume remains unchanged, pressure increases, therefore PV increases. And if delta PV increases, again, we analyzed this before. U, H, T, and PV must change in the same direction. So we can quickly just put this greater than sign for delta T, delta H, and delta U. And because delta V is 0, there's no expansion or compression, work must be 0. And delta U equals Q plus W. If delta U is positive, then Q must be positive because in this isochoric process, W is 0, delta U equals Q. So same thing here, the second column is simply the opposite of the first column. And then the third column is exactly the same as the first column, again because in the isochoric process, temperature is proportional to pressure, but let's do it anyway. Delta V is 0 for isochoric process, temperature increases, so we have a greater than sign here for delta T, and if delta T increases, the average kinetic energy goes up, the kinetic energy goes up, delta U goes up, because the potential energy is 0. Delta H increases, delta H is positive because delta U is positive, and also delta PV is positive. How about delta P? Again, I mean, if you think about this, if PV increases, while V remains constant, then pressure must increase. And then delta U is greater than 0, Q must be greater than 0. Why? Delta U equals Q for isochoric process because work is 0. Again, the fourth column is the opposite of the third column.